All right, let's go ahead and take a look at Unit 1, Day 4, Segment and Angle Addition. We're going to be solving problems using segment and angle addition, and we'll solve problems using angle bisectors. First, I want to remind you what a segment midpoint is. Okay, the midpoint of a segment is the point between two endpoints of a segment, and it's called a midpoint. Midpoint divides a line segment into two equal parts. And in general, we can say that a midpoint creates an equation for us that is one part equals the other part. Or we could say half equals half. Okay? But whenever we have another situation where we have a point that is just between two other points, not necessarily in the middle, we get another kind of relationship that occurs. So let's say we're given that we have 2 points, A and C, and they make a segment. And we have a third point that lies on the line segment. Let's put that right there, B. Then we can state the following. The length of AB plus the length of BC equals the total length of AC. Or in general, we say that we take the parts and we add them, the two parts, part plus part equals whole, the entire thing. And that works whether you're using A, B, C, it doesn't matter. It doesn't matter which parts we have. Even if it is the midpoint, this part plus this part still equals the total in any line segment that has another point on that line segment. Okay, so we can practice a little bit of work with that concept. All right. So in example 1, we've got point J between points A and B on line segment AB. We're going to draw a picture to represent this situation. So since we're going to use several different numbers here, we're going to start by drawing one of the pictures here. We've got J is between A and B. So I'm going to put A and B as the endpoints, and that means J is somewhere in between here. All right. And we're told in this first case that if AJ, the distance from A to J is 8, and the distance from J to B is 7, then what would the entire length be? Well, remember the two parts add up to the whole. So we would do 8 plus 7 and get 15. Or we could have a similar situation where we know that the total length of AB is 12. Okay, so when I draw something like that, it's showing you that the entire length is 12. And JB is just 4, so J is only 4 from B. Well, in that case, we're going to take the total, and knowing that this plus my unknown here add up to 12, I could take 12 and subtract 4 to get that. That gets us 8. Okay, and lastly, our third case, this was A, this was B, this will be C. Our third case, if we are given this scenario that AJ is 8 and JB is 8, you'll notice that these are equal parts now, so we should recognize that point J is called the midpoint, and that's my abbreviation. MDPT period is the abbreviation for midpoint. All right, so if these are equal parts, we know it has to be the midpoint. And the total we could still find to be 16. All right, we can also use different problem-solving elements when doing this, knowing that AB and BC add up to give you AC in total. Remember, we are not told in this case that B is the midpoint. It probably won't be. 2x and 3x minus 1 probably won't be the same value. Okay, but we can still set up an equation to solve this. We do know that these parts add up to the whole thing, and we are told right here that the entire length of AC is 9. That means the sum of these two expressions, 2x plus 3x minus 1, that sum must equal 9. Okay, so to solve this equation, we combine like terms first. Then we add 1 to both sides. Then we divide by 5 to get rid of that one, and we get that x equals 2. Well, that's part of our answer, but it asks you to find the length of BC also, so you got to make sure you're finishing the problem that was given to you. We did solve for x, and we have that answer, but we now need to plug that back in and evaluate. 3 times 2 is 6. 6 minus 1 is 5. So BC is 5. All right? And that leads us to our third example. Same kind of idea here, only instead of giving you a number for this length, we're given another expression. So you'll notice that when I'm given the diagram, I start by filling in the pieces that I know. And that's going to help me set up an equation, because you'll recognize these lengths should add together to give you a total length. So I can write my equation, x plus 4. I'm just underlining these to show you the parts that are adding together, plus 2x minus 10 should equal the total from AC, 2x plus 1. And now all we have to do is start to simplify and solve this equation until we have a value of x, and then we can plug it in to find these other pieces. Why don't you go ahead and pause the video and give yourself time to go ahead and solve this equation, figure out what x is, and then plug it into each of these expressions to find these 3 segment lengths. All right, if you need any more time, pause the video. Otherwise, these are the answers we should end up with. When you solve the equation and you combine like terms, x plus 2x is 3x, 4 plus negative 10 is minus 6, and we still have 2x plus 1 over here. We should subtract 2x from both sides, and then add 7 to both sides. I'm sorry, add 6. My brain jumped ahead and did the addition first. We should add 6 to both sides. And so, x equals 7. All right? And now we just plug that in here. 7 plus 4 equals 11. So AB is 11. 7 times 2 is 14. 14 minus 10 is 4. Now, you can plug it in for this and get your total, or you could just add these two and get your total, and it should work out the same either way. The total should be 15 for AC. Okay? Let's go ahead and turn the page. Now, we're going to talk about what an angle bisector is now. An angle bisector works for angles the same way a midpoint or segment bisector works for segments. And that is to say this: an angle bisector is either a ray, like this, or any line or segment. Sorry, kind of ran out of room. Line or segment that divides an angle into two equal, I'll put the symbol this time, parts. And so our congruent statement from this is that, we could also say congruent parts, is that this angle and this angle are congruent to one another. This is your symbol for congruent. An equal sign with a squiggle above it means congruent, or having the same measure. So one angle we call LKM, so angle LKM, that must be congruent to the other angle MKJ. And in general, again, we have the situation that the part equals the part. 1/2 equals the other half. All right? Okay, and so we can work out some examples like this. Now, in each of these cases, we're given one angle measure, and there are two other angles represented. We have this angle that we're looking for, and the total, again, that we're looking for in this case. Well, if this is an angle bisector, we know these two parts have to be the same. So that angle is 37 degrees. And the total would be 37 plus 37, or the sum of both of those two, or 37 doubled. And 37 times 2, or 37 plus 37, is 74 degrees. Now in this example, we are given the total is 75 degrees, not just this one. It's kind of drawn in a weird way, but both of these together add up to 75. So each of these is half of 75. And so when we do that division, we get 37.5 degrees for both. You can write it twice or just write it once like I've done. Okay? So we've got another case here where we have a segment bisector, and they've given you these expressions instead of angle measures exactly with numbers. And so we can still solve this problem and find the measure of the angle by finding out what x is first. And in order to do that, we just set these two values equal to each other. So we can say that 5x minus 17 has to equal 3x plus 14. And I only know that because it's an angle bisector. So they must be equal because it's an angle bisector. That is a 3x plus 14. All right? And so we start to solve this equation by subtracting 3x from both sides, giving you 2x minus 17 equals, when we do just 14 there, and then we add 17 to both sides, we get 2x equals 31, and we divide by 2, we get that x equals 15.5. It's okay to get decimals. And then to find the measure of angle ABC, we're going to plug it into one of these and then just double that amount. And so if I plug it in here, okay, and I do that calculation for you, five times 15.5, and then we subtract 17, we get 60.5 degrees, and we need to double that to get ABC, the total. So we get 121 degrees for the measure of angle ABC. Okay? And so we have one more key idea to talk about here, and that's what's called the angle addition postulate. And here's what it says. If we have point B that lies in the interior, that means inside, of an angle, okay, so we get an angle, we'll call it X, Y, Z, and point B is on the interior of that angle, and we draw a line through that. This postulate states the measure of the sums of these two smaller angles is equal to the whole angle, or in general, once again, we have the concept that the part plus the other part equals the whole thing. So this angle plus this smaller angle should add up to the big angle putting them together. And there's the bell, but the video is still going, so let's keep going. So let's find these angle measures. Now we've got two angles that are not the same measure. This is 82 degrees, this is 48. But remember, for the measure of angle CDE, this part plus this part equals the whole thing. So I'm going to add 82 plus 48. We get a total of 130 degrees for the measure of angle CDE, this entire thing. Okay? And now for this next part though, we will we're gonna pause on this. I'm about running out of time on my video, and so I don't want to spend too much time. But what I would like for you to do is to try and just draw an angle and fill in these labels to see if you can get it set up right. And then we'll talk about it. You can do the drawing right over here in this space. All right, put your drawing right there of an angle similar to this, where one angle of the smaller is 3x plus 7, and one of the bigger one, or one of the other smaller ones is 5x minus 2, and the whole thing is 61 degrees. Again, don't worry about measuring this out. I just want you to draw a rough sketch to see if you can figure that one out. And then we'll finish this one in class.